Okay, here's another cool example where we're going to have to use the combination of two different laws of differentiation. You see we have a product here, the product of 3x squared times the cube root of 9 minus 4x squared. But that second function is a composite function, so somewhere along the lines we're going to have to use the chain rule. On the surface, though, it's clear that we'll first be applying the product rule. We have to use both of them. Solution f of x equals 3x squared times 9 minus 4x squared to the 1/3. I just rewrote it with an exponential power instead of a radical. Then use the product and the power rules, which will involve a chain. So we have f prime of x is equal to the first times the derivative of the second plus the second plus the second times the derivative of the first. That's the power rule. First times the derivative of the second plus second times the derivative of the first. Okay, let's find these derivatives. That's equal to the first, 3x squared, times, okay, hold on. We're going to take the derivative of 9 minus 4x squared to the 1/3 power. Okay, first we're going to apply the power rule, but we have to hit it with the chain rule. So this is 1/3 times 9 minus 4x squared raised to the 1/3 minus 3/3, right? We subtract 1 from the exponent, so we get the power negative 2/3. Now hit it with the derivative of the inner function times negative 4 times 2 times x to the first, which is negative 8x, plus, okay, take the other dude. He's 9 minus 4x squared to the 1/3 times the derivative of 3x squared by the product rule. It gives us 6x. So we have negative 8x cubed times 9 minus 4x squared to the negative 2/3 plus 6x in the front times 9 minus 4x squared to the 1/3. Now factor out the greatest common factor out of these two terms. The greatest common factor would be x, well, anyway, the highest power of x, we didn't pull out the factor of 2, times 9 minus 4x squared to the negative 2/3, and that leaves negative 8x squared times 1 plus 6 times 9 minus 4x squared. Just look at it carefully. That's what's left when you pull out x times 9 minus 4x squared to the negative 2/3. That's equal to x times negative 8x squared plus 54 minus 24x squared when we distribute multiplication by 6 over the denominator, which is now 9 minus 4x squared to the positive 2/3 power, and that simplifies to x times negative 32x squared plus 54 over 9 minus 4x squared to the 2/3. We could have done better than that. There's a numerical common factor upstairs that we should have pulled out. I regret that we didn't do it earlier. What is that common factor? Let's see. 54 is 9 times 6. I think it's just a factor of what? 2. 9 times 6. 2 times 3. And a numerical factor of, I believe, just 2. Leaving, what, 16 plus, let's see, 3 times, you figure it out.